Today we're going to go over solving systems of linear inequalities. Now this is very similar to what we did in Chapter 2, Lesson 2.8. We graphed a line, figured out if we were going to use a solid or a dashed line, and then we had to see where we were going to shade, either above the line or below the line. We did that by plugging in 0, 0. We wanted to see if, when we plugged it in, if that would make that inequality true. So what we're going to do today is we're going to graph one line, make sure if it's solid or dashed, then shade it. Then we'll graph the second line, do the same thing. Then where the double arrowed region is, where they're both shaded together, that would be our solutions for these two inequalities. Because remember, a system is when we have two or more equations or inequalities in a single problem. So remember, when we are graphing these, if we have a greater than or less than sign, we use a dashed line. If we have a greater than or equal to or less than or equal to, we use a solid line. And then also remember, with inequalities, if we get our inequality in slope-intercept form, so get the y all by itself, we would have to, and if we divided by a negative, we have to flip that inequality. So if we multiply or divide our inequality by a negative number, we flip the inequality symbol. Okay, so let's go ahead and try one. These two inequalities, they're both in slope-intercept form. So here's my y-intercept, here's my slope. So plot your y-intercept first. So plot my y-intercept at 2. My slope is 3. Remember, that is 3 over 1. Now my slope is positive, so that means my whole line is going to be going upwards from left to right. Positive slope goes upwards. So up 1, 2, 3 to the right 1. You could also go down 3 to the left 1. This tells me it will be a solid line. So I can just connect that with a solid line. Remember, it's kind of tough for me to do a solid line or a straight line with my tablet. So just bear with me. I'll just use a line on here. Okay. So now we need to figure out which way to shade. Now you can plug 0, 0 in and see if it makes it true. Then you'd shade towards that point. Or we can think, since this is less than or equal to, where are the numbers going to be less than it? Will they be above or below the line? If it's less than, it will be below. Okay, so now we need to graph the second line. Here's my y-intercept at 4. My slope is negative 1 over 1. So that means I'm going to go down 1 to the right 1. It's negative, so it's going downwards. Down 1 to the right 1. Down 1 to the right 1. And so on. Now this is a dashed line. Now look, it's greater than. Where are the numbers greater than that line? Will they be above it or below it? Well, greater than will be above. Now where are those two lines crossing each other? Where are the both shaded regions? Over here. Okay? It's all this stuff over there. So you can shade all this area. Okay. Let's go on to the next one. Now these are both in standard form. What you could do is find your x and y intercepts. So that means I would plug 0 in for y to see my x-intercept would be -3. Plug 0 in for x. My y-intercept would be -3. Or you can change these over to slope-intercept form. So I'd subtract x for both of them. So y is greater than or equal to -x minus 3. So I plot that, -3. It's my y-intercept. My slope is -1 over 1. So it's negative, it's going to go downwards. So down 1 to the right one. Down 1 to the right one. And also go up 1 to the left one. This is a solid line. So I'll put a solid line in there. Now I just have to figure out which way to graph it, which way to shade it. It's greater than, so we want numbers that are greater than it, so above this line. The next one, all I have to do is add 6x to both sides, and I have my y all by itself. So I plot my y-intercept at 1. I can go up 6 to the right one, or I can go down 6 to the left one, because it's 6 over 1. Okay, so my line is going upwards. That's going to be a dashed line. So dashed line. And now which way are we going to shade it? So we want the numbers that are less than this. So are they going to be above that line? Just think if you shift that line counterclockwise, this would be above, this would be below. So we want the numbers less than, so it would be below it. Now where are those lines, where are those two shaded areas crossing? Everything right in here. Along this line, and then here. So we'd shade all this area. If we're looking at the next one, I can get this one in slope-intercept form. 4x plus 2y greater than or equal to 8. So I subtract 4x from both sides. So I have 2y greater than or equal to -4x plus 8. Now I have to get the y all by itself, so I divide by 2. So y is greater than or equal to -2x plus 4. So I can go ahead and plot that one, -2x plus 4. So plus 4 is up here. My slope is -2, so it's going to be going downwards, my whole line. So I go down 2 to the right one, down 2 to the right one. Now if I look back at my inequality, it's going to be solid line. Sorry, that should be a solid line. Then where are the numbers greater than it? Numbers greater are above that line. So this way. Now I can plot the next one. The next one's already in slope-intercept form. So I plot my y-intercept at -3. My slope is -2 over 1, down 2 to the right 1. I can also go up 2 to the left 1. I can continue to do that. This is less than, so we're going to use a dashed line. And now figure out which way to shade it. Well, we want the numbers less than it, so will they be above that line or below it? They'll be below that line. So do these two graphs, will they ever cross? No, they won't. So our answer would be no solution. Remember, no solution, if lines are parallel, they will never touch each other. Now for this, our graphs are going away from each other. Their shaded regions are away from each other, so they will never cross. The next one, x plus y is greater than or equal to 3. So what we can do is subtract x from both sides. So y is greater than or equal to negative x plus 3. Or you can find the x and y intercepts. To find x-intercept, cover up y. To find y-intercept, cover up x. So I'm going to plot that at 3, down 1 over 1. Because our slope is negative 1. It's a dashed line. Okay, dashed line. And the numbers that are greater than it are going above the line. For this one, I would add x to both sides. So y is less than or equal to x minus 4. Plot that. So our y-intercept is negative 4. Our slope is 1 over 1. So I'm going up 1 over 1 to both sides. That's going to be a solid line. Now where are the numbers that are less than or equal to it? Below your line here. So the only spot where these are crossing, where they're both crossing, is here. This area over here. The next one, here I would add 3x to both sides. So I have y is greater than or equal to 3x minus 2. So plot it. Negative 2 is your y-intercept. Go up 3 over 1 for your slope. It's a greater than or equal to it, so we'll have a solid line. Now we want all numbers that are greater than it, so will it be above or below? It will be above your line. For this one, I have a couple steps. I would subtract 4x first. So I have 2y less than or negative 4x plus 6. Then divide everything by 2. You could have found your x and y intercepts. That's fine. But since we've been graphing in slope intercept form, I'm going to stay, working with that. So my y-intercept is 3. My slope is negative 2. So I'm going down 2 over 1. Down 2 over 1. This one will be a dashed line. Now where the number is less than it, it will be below this line. So the areas where they cross is everything from this line down. Okay, we have 2 more quick ones. Y is greater than negative 3. This will be a horizontal line at negative 3. Okay? Because when it's a y, it's going to be horizontal. And it's dashed. And where the number is greater than it, above. X is greater than negative 1. Well, x means that it's going to be a vertical line. That will be a dashed line also. So vertical dash line at negative 1. Where are the numbers greater than negative 1? To your right. Okay, think about where are those numbers greater than negative 1. Well, 1 is greater than negative 1. So everything over this area would make both of our inequalities true. Okay. So y's are horizontal, x's are vertical. The last one, it'd be a solid line at 3, and greater than is going up. Then we have a dashed line at negative 1,